Tonight we're going to be discussing some latest techniques for improving the quality of results and RAG systems, including self-reflection and feedback. And Ryan was going to go through that, and he's got a couple of papers he wants to go through. And at this point, I'm going to just turn it over to him. That's okay.
Okay, sounds good. So I guess for those who don't know me, my name is Ryan Chase. I'm based in Los Angeles and new to the group. So I thought I'd take an opportunity to discuss some of the latest techniques in retrieval augmented generation. So I'll go ahead and share my screen. If you have any questions along the way, feel free to interrupt me. I'm sure a lot of the folks on the call here know a lot about this particular topic. So if you have anything to add that you think would be relevant, feel free to chime in.
Awesome.
Okay, perfect. So first, the papers that I wanted to discuss tonight are corrective retrieval augmented generation and self-RAG, learning to retrieve, generate, and critique through self-reflection. So these are advancements in hopes of improving the results from a retrieval augmented generation system. So for those who don't know, or just like a quick summary, retrieval augmented generation, or RAG, is this technique where a user asks a question to the large language model. That user's question gets converted to an embedding, and then there's semantic search that takes place to identify the most similar text from embeddings that you generate from sources. So these sources can be PDFs, they can be URLs from the web. Before you're allowing this system to be exposed to the user, you're basically ingesting all of this text, you're tokenizing it, you're splitting it into various chunks represented by a vector or numerical embedding. And then when the user performs the query, the algorithm returns the most relevant embeddings to that user's query, and then those embeddings are retrieved, provided to the large language model to help answer the user's questions. So it's just additional context that's provided to the large language model to answer the user's query. So the problem that these sometimes face is hallucination. If the, say, retrieved data is not relevant to the user's query, they kind of fall flat in those cases. So there's been a lot of work in the community recently to explore other possibilities, other approaches to solving this pretty common problem. And the two that I mentioned here, corrective RAG or self-RAG, are two of the more notable papers in this space. And there are lots. So
can I interrupt you for a second? So I want to understand, when you said that the data that was retrieved, right? This was the user provided data, right? I mean, like whatever the RAG was using. And you said that that data was not correct and the LLM basically hallucinated. So where was the problem? Was the semantic search where you did and provided was wrong, or the LLM interpreted it as wrong?
Good question. It can really be both cases. So some of these techniques actually handle both problems. So I think you're referring to, is the user's question maybe misworded, or they're not being very clear about what they're actually looking for. That is one kind of part of the problem that these solve for. The other part would be the data that you're chunking and creating embeddings for is actually not relevant to that user's query. So these systems are designed with the intention that, let's say, for corporations, they might have all of their documentation or their shipping policies, any sort of like information about their website contained in URLs and text in URLs. And they're providing a customer-facing chatbot for users to ask questions about, how to maybe make a purchase from that company, or they have a problem with an order or something. If that user's query, though, is outside of the bounds of what is being embedded here. And then the system fails over because it can't really retrieve relevant information to answer the user's question. So that's kind of the other class of problem where these systems sometimes fail.
Ryan, I had a couple questions, if I may.
Sure.
One, so I thought I heard you say that the embedding was provided to the LLM for context, but it's actually the text, the clear text from the chunk, I assume, that is provided.
Correct.
Yeah.
Correct. Yeah. Sorry, that was just more of an oversight in terms of how I was describing it. But yes, that's correct. So basically, what's happening under the hood when you're building these indexes is you're tokenizing the text and then splitting it into chunks and then creating embeddings from those chunks. And then in a multi-dimensional space, that user's question is also converted into embedding, and then the matching is happening in that kind of multi-dimensional space. At the time that the closest embeddings are identified, those are converted back into text, and that's why relevant text here. Yeah. And then it gets fed into the large language model because it can be understood as natural language.
Right. And then the second question, so do you know what type of, so the chunking, is that just an arbitrary fixed number of tokens? Is there some sort of, I don't know, semantic boundaries that are established? And kind of what size are they?
Yeah, good question. That varies. So sometimes you'll want to chunk based on like an entire page. These libraries can allow you to define how you want to chunk that data. Okay. One common thing for the boundary is to create an overlap. So you'll define how many characters or how many tokens that you'd want to overlap the chunks so that you're not, let's say important context is spans the across two different chunks of that data, you'd want to actually include that. So you'll kind of create an overlap in that case and make sure that you're including all the relevant data.
Sure, that makes sense. And then the last one, when you find embeddings, is there any sort of kind of proximity? Like I'm imagining I find this paragraph or this page of this document and there is additional context. Maybe that was the best match, but there's additional context that might come out of, nearby or related pages.
I think there's kind of maybe two ways to answer that question. One is a lot of the times you're using a vector database. You're mostly using a vector database for this process. So there's like Chroma, which I'll show in the code examples, Pinecone, Google Cloud, they all have vector databases. There's a few of them off the shelf. You can associate metadata with these embeddings. So a lot of times you'll have the text that was actually created into the embedding as part of the metadata. And you can also associate things like the page number so that if you're wanting, say, to have citations provided to the end user, that can be easily achieved through that additional metadata that you're including in the embedding. Gotcha. Some vector stores allow that capability. I know Pinecone, for example, does. Some of them don't. So that's a feature that's not uniformly available across vector data store providers.
Okay, thank you.
So to add to what Ryan was saying to Roger's question, most of the time what will happen is that you will get a set of these matches and you need to run it through another mechanism to do a priority on them. And so what happens is through that you will possibly give the user a preference of the first two or three kind of things. So that's one. The other method also that is used is you take the sections and you create a pre-list of questions it could possibly answer, the chunks. And what you do is then you do a semantic thing on the question. So saying, hey, this is the question that the user is asking. Do I have a similar question that could have been answered? So what you do is in that you change the size of the chunk quite a lot. So that's a lot deeper than doing standard chunking. So you have a hierarchical thing of those chunking, and those are also what you call is when you go across the documents, you have built that tree walk that you would do. So now you have a starting context of that question, and then you can blow it up. Then you say that, hey, this also. And so if you, I don't know if you've seen Perplexity or not, they say that this answers the question, but these are the other questions also that can be answered, right? It also pushes the question to you also, so that you don't have to type the question. But those questions are basically pre-generated. It knows the exact answers to that. So if you're in the vicinity of those questions, you know, hey, this is exactly what I was asking for, because that is the ability of the LLM to answer correctly. Beyond that, it starts to hallucinate. So I don't know if I answered it. I was
Now
little-
that's very interesting. So that's a lot more sophisticated embedding generation than I
Yes.
understood. So
Yeah.
very cool.
Yeah, thanks for adding that.
But one other question, if I may.
Yeah.
So if I understand this correctly, there is matching going on in the semantic space with some chunking, hierarchical matching, ranking after that. And then, so that's one thing. And then the text is found, that's a closest match, and then provided to the LLM, right? So in the first half, were there other methods that were tried besides encoding match? Like, you know, if you put it through a search engine, for example,
Yeah. So
you
usually
could
that
get
is
some
done.
relevant text.
It's done, but I don't see in the slide over here. So you run it through other Elasticsearch and things like that. And so you do a ranking on those two as well. So
I
you
see.
whether the semantic is actually better versus the actual Elasticsearch that it is showing up, right? So the
I see.
will show for popularity of words versus this will have a
Mhm.
to it. So
Right. Okay. Okay. Thanks.
Yeah,
And the other, sorry, one other question is, does it always answer, you know, like a classification problem where it always classifies, even if it is, you know, given a sample that's outside the distribution? Does it always answer, or does it say, you know, can it figure out the distance is too large, I can't answer this question?
So two answers there. First, the first topic area is called hybrid search. You'll see that is listed as like hybrid search in documents, and deeplearning.ai had a really great video recently about how to perform hybrid search. So you're using half semantic search and half like keyword type of search, or like a more traditional search, and you can actually define that parameter on how much you want to for it to depend on semantic search versus like a more traditional search.
Got it.
The second question is that this is actually just augmented. So it's called retrieval augmented generation. So anything that it can extract from the embeddings, it's just augmented along with the user's question to the large language model. So it doesn't have, to my knowledge, at least in most of these systems, it doesn't have a way potentially to identify how maybe far these are from the user's question and the query that gets embedded. I'm sure there are potential certain ways in the algorithm to define, you know, how many neighbors that you want it to retrieve, and there's like certain heuristics around that and controls. But I think what I'm going to specify in this the rest of this session are ways to defend against that case where you're actually getting results that are really poor, for example. That's kind of the purpose of this next evolution. So this is just sort of painting creating the framework about what is retrieval augmented generation. But I think the point that you mentioned there is the exact thing that these approaches that I'm going to show are designed to protect against.
Okay, thank you.
So the critical part is there are two different ways that what Ryan has suggested was, one is just the query embedding and looking at it. And there's the another one, which I was saying, that you have pre-generated questions. And what you do is you look what is the closest question that could possibly answer this question, right? And that is what you basically pull the contents of that and give it to the LLM. So that's a different method of doing that, but that has a lot more what you call contained, and the boundaries contained to it. Versus here, the LLM has already gone through it and knows what all chunks it can potentially answer. So that's like two-phase. You have to run two phases on it. So
Got it.
Yeah.
I guess with the sort of pre-canned questions, it's more constrained, it's more biased. There's less variability in the output.
that's right.
Yeah, it's pretty cool creating the questions from the text. It's almost like you're studying for an exam and you've read the textbook and then you're trying to create questions or anticipate what questions could be asked or something. So pretty cool. I didn't know that technique existed. So for these papers, I was kind of loosely following an example that the LangChain team provided, where they actually demonstrate ways in which you can defend against that problem, where the text that you're returning, the augmented results that you're returning are poor. So there's kind of two classes of thought with this in the industry. One is an agent-based system, and then there's kind of this reflective, self-reflection based approach. And so we're going to talk about the more self-reflection based approach and some of the kind of cool techniques and the libraries that are being developed in this space to help this specific problem. So this is a notebook I just pulled from the LangChain LangGraph repository. I'll link this if you want. But essentially, this is what we're going to create. So the user asks a question. We're going to use Nomic for our embedding model, and then we're going to ask it to grade the results, right? So this is kind of that reflection node. The output here, we're using Ollama's JSON output. So we're constraining the output to JSON. This is another nice thing about using Ollama. So this was my first time using Ollama. Ollama is kind of like Hugging Face from how I understand it. It's you're able to download it and then you can download models locally. They make it very easy to do that. And this JSON output thing that was pretty interesting with that type of with the Ollama model. So you can output the JSON. In the JSON, you can specify another node. Are these documents relevant? And then in the DAG, you kind of have this division here. If they're not relevant, I think this is backwards here, but if they're not relevant, irrelevant, any documents irrelevant. If they are irrelevant, we want to rewrite the query. And that's kind of, Jayant, I think you were asking a question around what if the user's poorly, is sort of like writing it in a poor way, or maybe Roger, you asked that question. This would handle that scenario. And then we can also perform web search. So these are kind of additional tools that we have in the tool belt to arrive at the correct answer. So if it's not contained in the index that we created, let's rewrite the query, try it again. Otherwise, let's use web search. And for the web search piece, we use Tavily, this framework for performing web search. And then if the documents are relevant and they're not irrelevant, then we can just perform our generation. So the way that we're constructing this is kind of like a pipeline in Vertex pipelines or machine learning pipelines. And you'll see where we actually create the DAG and compile the DAG, and then we run the DAG, which is a really interesting kind of approach. So a few things to note if you're trying this notebook yourself. One is that running just pip install ChromaDB failed for me. And I checked in the GitHub issue. Apparently, you basically have to set this HNSW lib to known native environment variable equal to 1. And so this is a problem with Mac OS, and it's trying to convert something in this ChromaDB library into the C++ version. And so you need to first create this environment variable. And then once I ran that, then you can go ahead and install ChromaDB. So that was just like a little bug that I hit early in the notebook. So just a heads up there. We have an example.
The HNSW is actually quite a powerful technique over there. So what you want to do is get that fixed, get the Xcode installed, and have your CLang compilers and all installed. So it probably does local install, I think. I don't know about the specific one, but that is used quite a lot. So
yeah, I know it's a pretty commonly used package.
Yeah.
I tried Xcode, it didn't work for me.
no, but what I meant is that particular HNSW. So that's called as a hierarchical navigational something. It's called. It's a pretty big acronym.
Yeah.
Yeah. So get that working is what I was saying eventually.
Okay. Okay. It's just this native flag. It didn't. The C++ compiler didn't recognize the native flag. So that was the specific error had to do with the native flag. So I was just setting it to 1. So anyway, that seemed to work. I'd love to understand kind of the interworkings of that package and what's going on there further. We're also going to install Mistral or use Mistral as a potential or as our core large language model. So here we're using Ollama and just pull Mistral latest. In the video that they do a walkthrough, they use Mistral instruct. And I was getting an error on that one too. So I found that latest seemed to work. I'm not sure how familiar you are with Ollama on the call here, but basically you have to download it and then it lives locally. And then you can just find the model that you care about. So in this case, we just search like the Mistral set of models, and then you can go to tags here and find the tag of a model that you want to use. So here's the instruct, and here's the latest, and you just specify that in your notebook here. And then it actually loads that model locally. So now you have the large language model living locally in the machine. I'm using a virtual environment here with in the notebook. And then, as I mentioned, Tavali for the web search. So you just go to Tavali, get your API key, just like you do with any other service kind of in this space. And then we're also using LangChain's LangGraph, Langsmith, specifically LangGraph. So as I mentioned, when we're creating this kind of DAG, it's executing each step sequentially, and we define how that DAG looks later on here in the code. LangGraph is letting you actually see what the output is, the intermediary output from each one of those steps. So pretty cool, because we need to do self-reflection here. We need to generate like let's say create our retrievals, get the text retrieved from the most similar embedding, and then we want to perform a reflection step where we're asking, is this relevant to answering the question? And if it is, then in our JSON output say yes, and if not, just say no. And with LangGraph, it's pretty cool because you can actually get in there and see what is the intermediary output of each one of the nodes in that graph. So basically, this is, pretty standard boilerplate for working with these. So we'll start with this as our single URL for retrieving information. So this was all just included in the code initially, but it's this blog post about agents. And then, so we'll load in that data. We'll split it. So we talked earlier about like defining that chunk size. In this case, they're just using a pretty standard 500 token length of chunks. And then they're creating an overlap of 100 of those chunks. They're then splitting that up into these chunk sizes that we specified. So text splitter here is what we just defined, and we're splitting the documents. Docs is our URL, basically that we loaded up. There was a little bit of a bug here in the code. If you try this code yourself also, I commented out those 2 lines, but basically I just had these swapped. And so they won't work if it's swapped, just heads up. We're using GPT-4 all embeddings. That's what I mentioned before, doing it all locally. And then here's Chroma. This is our vector database where we're going to be converting all of the text embeddings and the chunks into embeddings.
Is that vectorizing? Is that a streaming type of function, or are you pulling the full document in, splitting it all, and then passing that down?
I believe it loads it all into memory, because if that's your question, because this is the
Yeah.
URL. Yeah. I don't know definitively. I can't say definitively on this call. I'd have to confirm. Yeah, we need to confirm on that. I'm not sure how the loop works. So, once we just kind of have that defined, and we have our retriever, which is our vector store, basically, then you have this flag here. If run local is yes, then, use our Ollama model for chat. And here's that JSON output. So as I mentioned, you're constraining the outputs to JSON. This is important in self-reflection because we need it to be able to pick out the important pieces to define where we need to go in our graph. If we need to send it to the generation node, or if we need to first, do a web search or rephrase the question. So this is pretty cool in this library that you can output as JSON. Here we have this prompt template. It says you are a grader assessing the relevance of a retrieved document to a user question. Here's the document. Here's the question. If the document contains keywords related to the user's question, then grade it as relevant. That's kind of the output. And then at the end, you're saying provide a binary score as a JSON with a single key score and no preamble or explanation. And so what you see here is we're asking the question agent memory. That's our query. That's our user's query. We're just saying agent memory, which is a pretty poorly formed question. But because our text is about agents, the output here in JSON says score yes. So it scored it. That's that reflection piece. And then it's saying, yes, it is related. These retrieved documents are related to that user's question. We define our generate like functions as well. And the key thing here is just the prompt chain. So we're providing it with the prompt, sending it to the LLM that we're defining here, which is our chat Ollama model, and then string out parser. And I'm not as familiar with the LangChain library, but apparently this is a pretty standard way of defining those chains.
Ryan, can you define what it means by it says RLM/RAG prompt? What exactly is that? If you know, sorry.
Yeah, I don't know.
Okay.
What that piece is.
Or was that something we set up earlier, perhaps? Maybe.
Let me search for hub, actually. It's a good question.
Yeah, I didn't mean to, just if you knew.
No, I'm curious myself.
Yeah.
So just
From LangChain import hub. Something we're pulled from the LangChain library. Let me take this follow-up. I'm not sure exactly what it does.
Okay, fine. Yeah.
Obviously, it's included in the prompt chain here. As I mentioned, I'm not as familiar with LangChain, so this was kind of my first foray using the library. I've used it for interacting or interfacing with different like vector databases, for example, but in terms of like chaining the prompts together and DAG, this is the first time I've used it, so I'm unfamiliar with that.
Yeah.
Structure. So, remember our question was, our score was yes, so that we're saying that the retrieved documents are related to that user's question, and the user's question is agent memory. So because of that, we're sending it directly to the generation node. We're saying, hey, run the generation on this. And then it just says the given text discusses the concept of building autonomous agents using large language models, blah, blah, blah. So it's, answering that user's question, which is agent memory, in a very verbose way here. Yeah, so here is a rewrite. So it's fairly self-explanatory here. You're basically saying you're a question rewriter that converts the input question to a better version that is for vector store retrieval. Look at the initial formula and improved question. Here's the initial question, improved question with no preamble, and you're suggesting it here. So the input variables are your generation and a question. So this is very simple. It's very simple. It's just prompt engineering, and you're just specifying to the large language model to rewrite the user's question so that it would, enhance the retrieval from a vector store. And so here's what it does. Instead of the agent just acting, instead of the user just acting agent memory, it's rephrasing the question. What is agent memory, and how can it be effectively utilized in vector database retrieval? So a much more, elaborate question. This is the kind of fun part. So as you're moving along from state to state, or from a node to node in this graph that we're creating, we're actually going to maintain the state, and that state is a dict with question generation, web search, and documents. And this is kind of similar to if you use like Anthropic's model or any of these large language models, you're providing the user's query along with the generation of like each turn in the conversation. This is similar. You're kind of keeping track of these things and moving them along in the node, along the graph. So we define what the graph will look like, that state will look like in our retrieve and generate step, and see how you're sending the state to retrieve, you're sending the state to our generate function, etc. So you're just passing the state to each one of those nodes. And here we're basically, in this part of the code, we're having it output, we're printing out the grades. So we know, as we're running this code, at least on the back end, as we're developing it, we know how it's thinking about the text that it retrieved and what its next step should be in this graph. And I think this was really cool because it kind of makes it very verbose and very clear what it's running. And so I'll show this here in just a second. I'm just going to skip down to it. This is essentially what it looks like when we're running our code. It's saying check document relevance to question, grade the document relevant, grade document relevant for each document that it's retrieving. Is it relevant? And if it's, based on the assessment, because they're relevant documents, okay, we're just going to generate our text now. So we're going to send the augmented retrieval that we retrieve from the sources, and we're going to send it to our large language model to generate an answer for the user. And then you get just the generation here in the output. So this kind of information around how it's arriving at the decision, I thought was really cool. It's kind of a little glimpse into what's happening under the hood, which I think is going to be important in this space. And I mentioned this here, I'll click this, smith.langchain. This reminds me of Vertex pipelines. If you've ever used Google Cloud Vertex pipelines a little bit, because this is where it's actually producing the input and the output along each step of the node, which is pretty slick. So here you can see score, yes, you know, and you can see our prompt template here included in the UI, and it's able to be referenced at any point later in time. So you can kind of follow exactly how it arrived at the answer, you know, that it did, and get the intermediary outputs along the way. So yeah, I think that was cool, Lang Smith. The step right above this, though, where we actually compile, this is kind of where we're defining our kind of set of steps, the nodes and the edges along the way. So everything that we defined above, where we're saying, you know, this is a generate step, or this is a retrieve step, or this is a grade document step. Here we're actually kind of adding nodes to that DAG, and then at the very end we just compile the whole workflow, and then run it. So yeah, that's it. And then here's the last example, so you can see an example where the documents that it retrieved are not relevant to the user's search. So here the user's question is, how does the alpha codium paper work? This isn't, I guess, at all related to agents and what we have indexed in our vector database in Chroma. And so the output here, as it checks the document's relevance to the user's question, it says that it's not relevant in every case. And then because it's not relevant, then the decision is to transform the query. So instead, it's going to change the query and then ultimately perform a web search. And then online, it just performs a web search, and then based on the information it retrieves in the web, return the correct answer to the user.
Well, that's really nice that it shows you its kind of logic it's going through, you know?
Yeah. And then also, you know, LangSmith is doing the same by kind of having this UI that you can click into, and, you know, maybe that's more user-friendly for some folks to kind of debug and understand where it went wrong, and then they can help inform the prompt template and the way that you're designing the DAG and so on and so forth.
So I'm not quite following that. So that the link you're following to this visualization, yeah, that. So that's generated every time I make a call to whatever the generate here is, or let's see, where do I actually do it?
Yeah.
Inputs, output.
I guess it's this p print, the value of the generation. So
Value and app. Okay, the app. So it's app.stream the inputs is what, and it's generating multiple outputs to it. Okay, but somehow that's then putting that into another website. Is that uploading the results to the other website?
yes, at the very beginning, we defined that we wanted to use LangSmith, and that's an optional. I'm sorry, let me find it. That's an optional thing that you can add if you want.
Okay.
Sorry. I'm making you guys dizzy here. Okay, here we go. LangChain tracing.
Okay.
And setting that environment variable to true, and then the endpoint is just the standard api.smith.langchain.com, and then I had to create a LangChain key. And
okay.
I'm saving that API key, by the way, in a .env file. I think most people know that. If you save it in .env, it doesn't show here, but you can use os.getenv, and it will actually load the extract the environment variables, and you can then use them in your code here. So because the way that they have it in the code is to just list your API key here, like explicitly. So yeah, I run this, here, let me show you one more thing. At the beginning of my code, I just kind of get used to this. So it's after the ChromaDB stuff, sorry. Right here, .env is the Python package I use, python-.env, and then from .env, import load.env, and then load.env. And the environment variables are just listed in this .env file, like .env. And then it'll just, so it looks like this. I'll just show the file is like .env, and then in that file it just says like, you know, open AI API key equals, and then my key. And so that's all that dot environment file it has inside of it. But this is a really nice way of not exposing your API keys to everyone on the meetup, or, you know,
Right.
You probably already know that, but yeah, that's
So it's set detached from the notebook, but it's in your virtual machine where you're running it.
yeah. And I'm just using my local machine on this. This is all, yeah. And it's detached from the notebook, right? And also it's a .env, so if you upload to GitHub or something, it's not that gets ignored, and then you don't include it. So this is kind of a nice workaround for hiding those keys. But to answer your question about the Langsmith, apparently this is what you need to set in terms of the environment variables, and then I think it's being referenced at some point in the code here as well.
Okay.
I would need to follow up and check exactly how that's being brought in.
But generally, are you running a local LLM here in your case?
That's right. Yeah.
Okay, so everything's local, but then kind of the results, if you want to visualize that using that Langsmith, then you have to upload the results to be able to visualize them.
Yes. Yeah, this is over the web. I believe that's not using a local server. That's a good test for me as well, just to understand if this is running on the local server, just like my notebook is, but I didn't spin up anything.
Doesn't look like it,
on my
yeah.
terminal. Yeah. I just accessed it from the web. So yeah, I think it's kind of loaded upward.
And is
I'll follow up on that.
Is that same information captured? What was the at the bottom where it provided the link? It was also.
Oh yeah, at the bottom, right
Is
here.
there an object there? If you scroll up, then is there an object that's generated that has all the same information already? Output. Node.
Like what has already been oh, you mean for both cases? Okay, so let me click on this one and see if we can see it. I see what you're saying.
In other words, is this just a presentation, but you've got an object that captures all this locally in that notebook, is what I was wondering.
It
It doesn't look like it.
No, it's not capture. It's not. It's in the generate, because that's what we're printing here. The value of value here for key value and output dot item. So for output, this is pretty nested. And app.stream for those inputs, it looks like it has for output. And so for each value in this app.stream, there's a dot items.
So yeah, dictionary of things, yeah.
For key value and items, and one of those is what we're printing out here.
Well, I'm just wondering, can you uncomment that print full state in each node if this book is working? Is this live?
Yeah.
Yeah, so that, well, it prints out the node, but then optional print full state at each node. Just uncomment that pretty print.
Oh, okay. I see what you're saying. Yeah.
Oh, not that
no,
one.
one,
No,
one
not
line
the
below
next
that.
line. Yeah.
This one?
That one.
Yeah. Yeah.
and then execute it again, I guess.
Yeah.
Somebody does one.
Oh, just skip the pretty print dot. Yeah.
Oh, yeah, I think we have, yeah.
And then how about just
These
value?
take out this guy.
Yeah, that's what I'm wondering, but
There it is.
Oh, there we go.
documents. What else does it have? Well, it's got more stuff. I don't know if it's the same stuff. Yeah.
Yeah, I mean, this is after the web search, right? Yeah, this is after the web
Retrieve.
search.
Right. Check.
Oh yeah, that's a huge document with references. There's archive references, all sorts of things in there.
So this was the original source, right? Was this one? I believe. So, oh, it's
Lillian
this
Wings.
source here and here. This is pulling from the same source, just different pieces of the text.
It almost looks like it only did this for the first
Yeah.
node, right? Because then it prints out check document relevance.
Yeah, here's
And
the
we stop getting output. It's like it's been truncated.
Yeah, it has been.
Yeah.
Yeah, because this is all from the first
Step.
retrieval attempt, and
Yeah.
then we.
Yeah, interesting.
Oh wait, here's the question.
Is it still running?
Yeah, I think it is, and it's finding a bunch of non-relevant documents. Yeah, it is, because the stars are, there's no number.
Yeah. Okay. So it didn't get truncated. It's only made it that far.
Yeah, there's a few more non-relevants.
I was going to ask, like, how long does it take to, run this?
I noticed it's a little bit slow. Like you can see it's doing this grading and how slow it's running. I also used Mistral Instruct, or sorry, latest instead of Instruct. So I might have downloaded a larger model than what was intended for this demo.
And is it using GPU, CPU?
I'm just using my CPU.
Okay.
Okay.
Yeah, this is just a notebook instance. I'm surprised it's actually taking this long though. I thought it was a little bit faster than this.
Well, we can always just stop it if you want to move on then. Yeah.
There we go.
Oh, there we go.
Decision. All documents are not relevant to the question, so it's going to transform the query and then perform a web search. And here's the web search. Yeah, which is much more relevant. And then finally,
But not cited. It doesn't look like there's a citation embedded anywhere in there, is there?
good catch.
Huh.
It's pretty interesting stuff, though, the way it goes through its logic.
Yeah,
I'm actually surprised, Ryan. You were saying you're surprised it was taking this long. I'm actually surprised running in a language model in CPU is actually this fast.
I am also. I think I was referencing just previously. It seemed like it was running a little bit faster.
Oh, okay.
Earlier, yeah, but yeah, no, I'm also still pretty impressed that I was able to download it. It downloaded very quickly too. So this is it downloading it right from Olama. And this just cruised. It was just very quickly went through all of this, installed all of this. So I downloaded the entire model, and it maybe took, I don't know, a minute or a minute and a half, 2 minutes max to go through all of this. So I thought that was pretty impressive.
Which size model is this?
Let me check. 4 gigs. 7 billion.
7B quantized at 4 bit.
Okay.
Still.
Yeah, and I just think, you know, I haven't used Hugging Face very much, but I know they're kind of the leader in terms of model repositories, and I think Olama's, you know, focused on open source and running things locally, but I thought it was really interesting how easy it was to download Olama. It's an application that's on my MacBook now, and then I can, you know, run those commands, and if I want to download a different model, all I have to do is specify the model and the tag, just like that, and it will download it. So they couldn't have made it any easier to download a large language model onto your machine.
Mm-hmm.
Is there any relation to Hugging Face? I think in another, you know, in another session of our meetup, somebody had mentioned Hugging Face has sort of obfuscated the code or something like that. Is there any relation here with Olama, or how does, I'm trying to figure out how that works.
I'm not aware of any way in which they're connected. I think it's, you know, at least in my mind, and I might not have the full knowledge of the space, but in my mind, it works very similarly to Hugging Face in terms of, you know, downloading a model and using a model. Kind of, it's a model repository from my view, where, you know, I'm able to pull down models locally specifically. So I think they're fairly competitive, at least from that perspective, but I'm unsure of the, you know, all the different dynamics and at play there.
Okay, yeah, thanks.
Does LangChain work with both Olama and Hugging Face? Is that an independent?
Yeah. LangChain. So the way that I've used LangChain in the past is just for interoperability. For example, if I wanted to use Pinecone vector database and then I wanted to use Google vector database, the function calls and everything stays the same. So they've abstracted away kind of the client libraries that you would use for each of these services and made a consistent like type of function call.
Gotcha.
And that makes it really easy if you can just pull something off the shelf and say, oh, I want to use Vertex vector search, or I want to use Pinecone or something, and then you can quickly compare the results. So that's how I've typically used LangChain. This is my first time using LangChain to actually build a sequence of like chaining together different prompts, and it's kind of this concept of nodes. But so I think they're actually, I mean, that's the way I see their value, is really two-sided. One is providing this interoperability, very easy to work with different providers, and then also the ability to also chain things together. And now with Langsmith, the ability to have this kind of UI that shows you what you're building. And I love this JSON output. I thought that was really slick, that it's constraining it to JSON. Now you still have to mention it in the prompt, which I thought was strange. So you're saying provide a binary score as a JSON with a single key score, and, you know, no preamble or explanation. But you know, I think that's fairly easy and straightforward to do, and tell it in natural language what you want, and then it's sort of like just reinforced with this JSON mode. So
that's where you were specifying the language then, was it? Or the LLM as well, was it?
yeah.
Run local LLM, okay. And so that's some sort of wrapper, that Olama chat minstrel API is some sort of wrapper around the language model.
Find local LLM. Yeah. This is a a wrapper around the model. And then local LLM is just the one that we define. And I think the authors of this code just did that so that you could very quickly swap out a model and you're not stuck to using the Mistral model.
Right.
And we define it up here at the top. Yeah, here. Local LLM is your Mistral latest tab.
Yeah, run local.
So really easy to test out a different one and compare the results. So, you know, we could try the latest Llama model we were just talking about.
Right.
And this is a powerful tool from that perspective. Like at the beginning of the call, we were just talking about that model. Let's see if it's in Llama yet. It's Llama 3, right?
Yeah.
Oh.
Dated
Yeah.
8 months ago.
Good thing our meetup happened this evening and not this afternoon, huh?
Should we try it?
Yeah,
So-
if you can do that live.
Yes, there is a fun fact. I actually required signed agreement in Hugging Face to use Llama 3, but a few minutes ago I just downloaded it for free from Olama, and I have been using it, and it's like, wow, this was actually pretty fast.
You're one step ahead, always. All right. So I think I have to run this one. Yeah. Actually, no. Oh, I need to define the model. I need to download it. So this is that step, but we'll see how fast this one is. How long did it take you to load it?
David? No.
It took me like 5 minutes.
Huh.
Okay. Yeah, so you know, pretty quickly. 6, 7, 8, 9. It's almost a percentage per second.
It's not bad at all. How fast's your connection?
I'm on my parents' Wi-Fi.
Ah.
Not blazing speed, I'll tell you that much.
These are,
You don't have that 2 gigabyte per second link going hardwired to your computer.
hey, Jerry. So these are 4-bit quantization. So the size is not that big. I mean, it's 4 gigabytes, right?
Yeah, well, you could see there, it's
Yeah.
what?
Yeah.
Yeah, 4 gigs. So yeah.
And so what folks are saying is Llama 3 8 billion is better than Llama 2 70 billion. Already they're saying that. So that's where I was saying earlier, right? Once you use the quantization and all those tricks, what they're noticing is smaller models actually start outperforming the larger models. So you take the learning from the big model, bring it down into the small model, and then use it for your purpose, as opposed to answering the whole world. Your small view of whatever the world is, it answers much better.
Yeah, because you don't probably need 16-bit resolution.
No, you don't. So there is a technique by which they have said that the 4-bit is quite. There was a paper in Europe which actually covered that, where they went and looked at the different weights and things, and then they said that the 4-bit will be equally good compared to any of the other things. So that's the advantage of. So you don't lose the weights aren't that what you call widespread when they try to. So we are not losing accuracy. So sometimes you'll find the accuracy even better with the low bit quantization. Nobody has answered me why. They all give hand waving answers. But I think we should.
I can think of a reason why that would be. When you get way out there, and all these significant figures and things, it's easy to get trapped out in that space.
Yeah.
And then think, oh, it's good enough. And we're just going to stop here because we're not improving. But maybe, versus seeing bigger chunks, if you will, of change. And that's a common thing I've seen before.
I think a follow-up would be like if David is willing to do a Llama 3 beyond this, right? With the same data set, whatever Ryan has done, and just take it forward. And then we can basically, our learnings will kind of get crisper with whatever Llama 3 8B is showing. mostly I think everyone will jump to 8B now, Llama 3. So
I actually am pretty amazed because I usually run all the models in my laptop. It's not even a $1,000 laptop. It's like less than that. But this time I was able to run Llama on the GPU. It's crazy fast running on my laptop, and it's nearly as good as GPT 3.5 as
Oh,
I am testing right now in my
Wow.
laptop.
yeah.
amazing.
So you can run even the Mixtral model also on the laptop. There's some
Yeah,
trick.
but not on the GPU laptop
Yes,
because
the
GPU
M3.
is only 8 gigabytes of VRAM.
Yeah, yeah. So folks have been doing that. They play this trick with, they add extra RAM and then they do some tricks, and then you can run the Mixtral model on the laptop. So
Yeah, with quantization, but even so, you just break the models into layers and you load some layers on the GPU and some other layers on the CPU. And that way you can run Mistral on the laptop.
yeah,
But it is still quite slow because the layers that are on the CPU are actually as a bottleneck for the model. But when you can load all the model in the GPU, it's actually pretty fast because
yes,
I can run Mistral, the Mid-Juras FP version on my laptop. But
Mm.
even when some of the layers are loaded on the GPU, it's still quite slow.
I see. Got it. Did you have to pay anything, Ryan? Because I saw there's a limit on the tracing, right? There's a 5,000 limit tracing and things. How much were you paying in terms of your credit card for this?
Good question. We'll see. It'll be a good experiment for me. I guess I wasn't expecting it to be material enough, but you're talking about
We'll take up a collection, Ryan, to send you.
No,
Maybe
I
we'll
would.
kick in a few bucks or something.
So what happened is we did some with OpenAI and we used their APIs, and people ran into $300, $400 within a day, and everybody,
man.
oh, it won't take that much, because what happens is it goes into loops and all.
I
And
hope we haven't done that for you.
Yeah, I hope we recorded Ryan's face just then.
I'm like, I'm mixing.
We'll take up a collection, Ryan, if it's that bad.
No, I'm not. I'm not worried. You said that was with OpenAI though?
Yeah, OpenAI. Yeah.
A big for-profit entity.
Yeah. For profit. All right, I was just logging in to see if I could find the billing. Just curious. But in the past, when I've used these, I haven't total tokens 18,000. Yeah, not that much. Was that aggregated? Yeah, I'm curious to find out. Let's see. I gotta go.
Oh, there it is. Oh, this is just the
5,000 free traces per month.
Yeah.
And then only 0.005 cent
Trace.
per trace. Yeah, that's pretty sneaky.
I would suggest that you put that usage limit which is there, so that you know that when things, what happens is sometimes you get loops and all, and you don't think about it, and later on you end up paying a bill. So
Yeah. Okay. Yeah. Thanks.
Yeah, that seems like a real good hint for any of us that are doing this.
Usage may take a couple of hours to show up, and yeah, really minimal today. Well, I mean, it said it might take a couple hours, so I don't know what time this is at, and the level of detail is only by day. It looks like you can't do it by minute or hours.
Yeah.
But 23 earlier, that's probably the first time I tried it. So yeah, curious to learn more. I know I had a few questions that I unfortunately had to leave unanswered. So I wrote some of those and I will follow up as well for next week. Let's see where this is at.
I have a general LLM question. Like how this is kind of primed with you are a question rewriter, etc. So it kind of takes the LLM down a path. Is it possible to get the LLM to retrace, to go back?
Yeah, I think you can just specify that in your logic. So this was our graph, right? And in this case, we just did a very simple split here based on if any of the documents are relevant. And this is the self-reflection piece that you're instrumenting when you're adding that prompt, and then you're instructing it to evaluate if the retrieval documents, the retrieved documents, are related in any way to the user's question. If you wanted to specify additional logic in here that says, if something is not related, or if you're not, 80% confident or something that you can return the right answer, like kind of go back to step one. I mean, you wouldn't say necessarily go back to step one, but you could say then, add a retrieve node here again and like try it again. But, maybe you'd want to rephrase it first. So that's why we had this like a rewrite. In our case, the rewrite was always done just before the web search, but you could always like rewrite and then try to retrieve again.
Okay.
That's one thing I found. That's one thing I found recently. So I was using the Wikipedia API, and I noticed that I was searching for a like sentence, right? Like in a natural language way. And the Wikipedia API is just looking for like titles of pages that it can return for you to find the information you need. And so I needed to rewrite that query that the user was expressing in terms of a title, in terms of a Wikipedia title. So yeah, you can always add like a rewrite node and then, do another retrieval or something in there.
What exactly does the rewrite node do?
Oh, the rewrite just rephrases the user's question. So yeah.
Or a web search, right?
For the web search specifically in this case. So like the user's question with the user input was really big. They just said agents or something. Where is it at? In this case, how does alpha codium paper work? That's the user's original question. And in the rewrite, transform query, what is described in the alpha codium paper about its functioning is the question that was rewritten to. And that's just helpful right before the web search node.
You didn't put in that question. It actually took your original question and came up with that?
Yeah, I specified and I didn't do this. This is just, me running through the existing code here.
Yeah,
but,
yeah.
But here it says you are in the prompt template for that node. This is the rewriter kind of node, if you will.
Oh,
Rewrite prompt. You say you are a question rewriter that converts an input question to a better version that is used for vector store retrieval. Look at the initial and formulate an improved question. Here is the initial question, improved question with no preamble, and then it lists, as you generate.
Got it.
Yeah. So, they're just kind of getting tricky. That's why these prompt engineer roles are arising, because it turns out that just directing it and trying to output the JSON from the response in some cases can, lead us to the next step rather than complicated logic. It's pretty wild.
Is there a bug in that? I mean, shouldn't it say web search instead of vector store retrieval?
Yeah, I think so. Yeah, good point. I think, again, I didn't write this, but maybe there's maybe they're, you know, fairly similar in terms of how you might phrase something. I'm not sure.
It also gives you the option of going back around for another vector storage retrieval.
Yeah, you're right. You're kind of setting yourself up to add that node. And I noticed in their notebooks that they have a lot of different notebooks. This one's just local. So for example, here's their repo. And, oh wait, this is LangChain community. Never mind. LangChain.
That was one question I had, as you mentioned DAG a number of times, which I assume is an acyclic graph. Does LangChain restrict you to not be cyclic then? In other words, can the LangChain create a graph that loops back again and asks the question, rephrases again?
I don't know. I think that's probably possible. I was using DAG kind of loosely just to define a graph more than I don't know about the ins and outs of what it can and can't do actually.
Okay.
So that question, Roger, what you asked is, sorry, go ahead, Julius.
It could be serial. You could have like, you know, a retrieval and then another retrieval node. It doesn't have to loop back necessarily. Mm-hmm. It could just be a deeper tree.
Right.
And that way you could set the count.
Right.
Yeah, well, easy to fix. Debugging LLM input is easier than other debugging.
Yeah.
Well, so if we can get some of the great output that you know that Ryan showed us coming out, that seemed to make it pretty straightforward as to what was it thinking, what, you know, because it's always, why did you do that? Why did this piece of code wander off and go do something I didn't think it was going to? And it looked like it gave you fairly good tracing on the logic it was going through.
So Ryan, if you can go back to the slide, I don't know, are you showing the examples?
Yeah, I was just going to quickly show. So these are all the other notebooks that were in this same repo. And so maybe they reused that, you know, where it's saying, hey, rephrase it in terms of a vector database. I think, you know, maybe this code was reused and they were kind of doing it for a different example. So sorry, you were saying go back to what, the code?
Yeah, just the slide. So I wanted to kind of elaborate on what Jayant had, I think, asked a question, right? Not this one, the one where you had in the Python notebook, right? You had that.
Yeah, right at the top.
Yeah, here. So what ends up happening is when you have a fork over there, typically the fork is not going to be answered by the, I mean, in this case, it's a simple one, but in the more complex scenarios, what you have is you have specific agents which will give you some hint as to what is going on over there, or you would query someone else, which are the fine-tuned, there are other LLMs which are involved as part of it. So what you do is the railing mechanism that you build, you make sure all along as you make progress that you are within the bounds. So you're always, side checking with someone else and making sure that the response is kind of going in the direction where it's expected to, and it does not start hallucinating. So that's how you build all the bounds around it with the agents. And with these LLMs, what ends up happening is you typically try to use some other LLMs to cross-verify that response with it, because some of these things are biased in their own opinions, right? So you can't really trace back and expect a different answer from the LLM. I mean, within reason, it will do a different answer, but what you have to do is you have to do a side query and say that, hey, this is what you're telling. Can some other reviewer who is good at this task come and tell me whether this is a valid answer or not, right? And that once it goes through the validity, you kind of push it towards the user. But if it doesn't fall through the validity, that is where you have those exceptions and the tracing becomes critical, because it goes back into your fine-tuning the reviewer. Now you're telling the reviewer is saying that what this LLM said and what I think is there's a discrepancy. So now you train it to make it better. That's the part of the feedback. So the DAG question that Julius had asked, right? You cannot like go back in that scenario. It's always like you're making progress going upward. the reverse way that what you're doing is LLHF, what people talk about, like doing the reinforcement learning and things. But that is as part of the agent framework that gets done. So you're kind of fine tuning the whole process as you go along.
I see. So it's almost like a ensemble of LLMs and some guardrails
Yes.
that each of them provide to the other.
Right, and they are supposed to be fine-tuned tasks. So they are fine-tuned on that particular. So you figure out who in the army zoo of LLMs is able to answer that question, and then you have to divert it to that. So that's why walking that graph is highly important. That somewhere like we made a mistake, right? So
Yeah.
think of a chatbot where you have all your supervisors and high-end guys, and the guy, before he responds back to the customer, verifies with everybody and then gives you a response, as opposed to saying whatever he feels like, right? Something like that.
Yeah. Okay. Thanks.
And another thing I would just add from the papers themselves, I know we didn't kind of dig deep into the papers, but there was a really, this is kind of an interesting graph or an interesting flow of basically what we had talked about. However, they also add this other step. If it's correct, they still do knowledge refinement. So if there's a lot of documents that are returned, then it kind of decomposes them, filters that to simplify it, condense it, and then recomposes. So this is like another, in the case that the retrieved results are correct, you can still add another edge and another node to further refine the results.
Does it only add one other node? I mean, there could be that N, right, produce. Do you know if it produces more than one in certain cases, or?
Oh, you define that completely.
Oh, that's a definable parameter then. Gotcha.
Yeah, so each one, and at the very bottom, I kind of breezed over this and I cruise down here. At the very bottom of the code where you compile the graph is where you specify all the nodes you want. I'm sorry, making it dizzy again. It's not too far. Right here. Sorry about that. When you build the graph, this is actually where you compile it. This is the last step where you compile it. But you can see you're adding all the nodes here, and you can just add the nodes that you want.
Oh, okay, I see. And those are then your parameters and things like that. Essentially, you're passing, or constraints or whatever you want to call them.
Yeah, and in each one of these, like you're naming it retrieve, and then you're passing it the retrieve function, and then if you find that retrieve function way up here, one of these retrieve here, and you're passing the state to the retrieve function. Each step along the way. So in this case, in state, specifically the question element of that state JSON format, you're specifying it there. So that's at a high level. You can just define whatever node you want with whatever function you want it to do. And then in the end, when you compile it, you're just adding those nodes. And
got it.
And there's a conditional node there.
So I think
look at that.
what will happen eventually is that, I don't know if you have read the Mixture of Experts paper, right?
The mixture one, yeah.
Yeah,
the
so
mixture of extras.
Yeah, so I believe eventually what will happen is you will have this giant LLM with these all mini LLMs as part of it, and this whole node thing will probably kind of go away, and you will have what is called as a project-based learning, right? Which says that I need my LLM to be able to answer these things, and there'll be portions of the LLM which will automatically start getting fine-tuned as you're running the documents through it, so that you don't have this composable node structure to do it. This is most likely a stopgap solution for like maybe a year or two before, because this is not maintainable. Get it? Because the feedback, everything, this is quite what you call painstaking. You need a lot of people to be doing that. A small company can't do that. I believe the Mixtral will kind of evolve towards having this giant LLM with smaller pieces of knowledge base, not knowledge base, but task-based LLMs within the whole system, which are all trained together. That the training part is the critical part of it. So,
Cool. Ryan, did you have anything more for us, or?
No, I don't. No, thanks for
Okay.
giving me the opportunity to talk, and sorry if it was a little basic for the group here, but
No,
I had a lot of fun building it, and it was fun, walking through the code, learning some things, and I was really impressed with Ollama. I was also impressed by how easy it is to do the web search with calories. So anyway, it was a good opportunity for me to learn some things. Hopefully you guys learned.
Well, I don't know about anybody else, but I really appreciate you. So thanks a lot. I mean,
Yeah, I
really,
thought it was
learned
great.
a lot.
That was
Yeah,
great. Very empowering, incredible.
Yeah.
Yeah. Yeah.